Okay, so we are starting chapter 6, and this will be the chapter that dictates what is on your final exam, okay? Quadratic functions, last chapter, we did a whole bunch of factoring. Now we will actually be able to use that factoring in order to graph quadratic functions. So we need some graph paper here. Okay, now, the thing that you are going to learn from me is not going to be exactly what is in your book. So listen up. Okay. Now, we are told to graph that function right there. Okay, now, that is a parabola because it is a second degree. Okay. Now, in order to avoid having to complete the square on this, to find the vertex, we are going to be able to utilize a couple of equations. And these will show up later in this chapter, but I'm going to show you that those two equations right now that allow us to find the vertex, h and k, of our quadratic function. Okay, so the h is equal to negative b over 2a, and the k value is equal to c minus b squared over 4a. So the very first thing that we are going to do before we graph this is find the vertex. Okay, so b is 2, so a is 1, b is 2, c is negative 3. Okay, so opposite of b would be negative 2 over 2 times the a value, which is 1. So we get negative 2 over 2, and we get a value of negative 1 for the h or the x value of our vertex. Now, for the k value, c is negative 3 minus b squared over 4 times a. So negative 3 minus 4 over 4 is negative 3 minus 1, which is negative 4. So the coordinates of our vertex are at negative 1, negative 4. Write these formulas down. Yes, you can use them on your final, but it's up to you to take notes. Okay, so here is the really big deal about what it means to understand the graph of a parabola. Now, this particular parabola has a leading coefficient, an a value of 1, when the a value is equal to 1. Here is the pattern that every parabola will follow when your a value equals 1. Start at your vertex. Go right 1, up 1, make a dot. Go left 1, up 1, make a dot. Go back to your vertex. Go right 2, up 4, make a dot. Left 2, up 4, and make a dot. And that is exactly what your parabola will look like. So, when a is equal to 1, start at the vertex. Go right 1, up 1, make a dot. Go left 1, up 1, make a dot. Then go right 2, up 4, make a dot, and go left 2, up 4, and make a dot. Now that's when A is equal to 1. And I will show you how to graph very easily when A is not equal to 1. Okay. So follow these rules right here. Okay. Following those rules right there will give you a very simple way to graph any quadratic when your A value is equal to 1. So instead of making an XY chart and filling in all these values, follow those rules. That's like a set of directions from your vertex to graph your parabola. Okay? That is example 1. And if you notice, they create this huge table with all these x values and got to fill in all the x values and square them and subtract and add and all that other stuff. We no longer have to do that. Okay, so we are going to look at example 2. And this is where I am going to help you with your, when your A value changes away from a 1. Okay, so we are going to graph y equals x squared, y equals 2x squared, and then we are going to graph y equals 1/2 squared. I know that in the book it's a negative, and we will talk about a negative in just a minute. Okay, so y equals x squared is the parent graph. We know the vertex is 0 because when x is 0, 0 squared gives you a y value of 0. So there is our vertex. Following our directions, we're going to go right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. So that is our parent graph. Okay? And regardless of what the value is in front of your x squared, drawing the parent graph first is definitely the way to go when you want to graph easily using the rules that I'm going to teach you. Okay, now from this parent graph, we are going to graph 2x squared. Okay, so in order to do that easily, what you do is you are going to multiply the y values of the parent graph by 2. All right, so let's start with the parent graph. This is the first point. The y value is 0. If you multiply that y value of 0 by 2, you still get a 0. Okay, now here's the next y value. That is a y value of 1. Okay, when you multiply that y value of 1 times 2, the x value is the same, but the y value is now 2. Now let's go to this y value. The y value is 4. 4 times 2 is 8. The x value remains the same. The y value goes up to 8. Okay, so that is the right side of the graph. The nice thing about parabolas is we have an axis of symmetry. The axis of symmetry is the line, let me get a better color here, is the line that splits the parabola in half, okay? And what that axis of symmetry does for us is it provides another point that is mirrored through that dotted blue line. In other words, this point right here is going to be mirrored through the dotted line over to here. This point up here is going to be mirrored through the dotted line, and we get another point over here. So the parabola y equals 2x squared is that red graph right there. And we get those points from the y values on the parent graph. Okay? So we take the y values, multiply them by 2, the x stays the same. So I'm going to add that here. X stays the same. Okay. And it is going to be the exact same case when we do y equals 1/2. Okay? When y is equal to 1/2 x, you are going to multiply the y values of the parent graph by 1/2. The x will stay the same. So, starting here, 1/2 times the y value of 0, anything times 0 is 0. Okay, now here's the y value of 1. 1/2 times 1 is 1/2. The x stays the same. The y is now 1/2. Here is our, here is our second parent y value of 4. Half of 4, or 1/2 times 4, is 2. Okay, so then of course that point down there will reflect over here, and the other point is going to reflect over here. And then the graph is the green one. So obviously you can see from the graphs that if your a value is greater than 1, the graph is steeper. If your a value is greater than 0 but less than 1, the graph opens wider. Okay? Now, one last thing. We need to understand what a negative value does to a graph. So here's what we're going to do. We are going to graph y equals negative 2x squared. Okay, so first thing we're going to do is plot the parent. The parent graph starts at the origin. Right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. Those are the points on the parent graph, okay? We are going to be multiplying our y values by negative 2. So, the y value of 0 down here, 0 times negative 2 is still 0. Okay, now this y value right here is 1. That y value, 1 times negative 2, is negative 2. The x stays the same. The y is now at negative 2. Up here, the x value, the y value is 4. 4 times negative 2 will put us down at negative 8. Right down here. So what a negative does, as you can see, is turns your parabola upside down. Okay? There you go. That's what a negative does to a parabola. Okay? So we've got equations that find the vertex. And now we know how to incorporate what we are calling a vertical stretch. That makes your graph more steep, or a vertical shrink, opens the graph wider, okay? That is the vertical stretch and the vertical shrink are from the numbers out front, right here, okay? Right here is a vertical stretch. The green is a vertical shrink, okay? And the negative turns it upside down. All right, so now what we're going to do is graph another transformation, very basic, okay? We will graph y equals x squared. That's our parent. Then we will graph y equals, actually, you know what? Let's graph from there. Let's start with 2x squared. Then from there, we will go to 2x squared plus 3, and then we will do 2x squared minus 2, okay? So that is going to give us another transformation. Now, what we're going to do is plot the points of the parent graph. Okay, so to get to the red graph, we are going to multiply all the y values by 2. So 0 times 2, that y value of 1 times 2, same x value, new y value. And then up there we have y is 4, now y is 8 with the same x value. So here are the coordinates for y equals 2x squared. Now, what we want to do is move that graph. Now, the plus 3 moves it up 3, and the minus 2 is going to move it down 2. So let's start with the green graph. We are going to take all the points on the red graph and move all of them up 3. So, the vertex is now right here. Each one of our points right here, move them up 3 and replot. And then, of course, those points up at the top, I just run out of room to graph those. Okay, so let's just... That is the graph, 2x squared moved up 3 units. Now we'll do the same thing with moving it down 2, okay? Take all the points from the red graph and move every single one of them down 2 units. So here's the vertex. Here are the next 2 points and the next 2 points. And that is your graph, 2x squared minus 2. Okay, very, very simple transformations so far. Okay, now we are going to one more graph. Let's graph y equals negative 3x squared plus 2. Okay, the first thing we're going to do is graph the parent function of the parabola. Just the dots are good. Right here, right here, right here, and right here. Now, in order to graph this properly, multiplication comes before addition. So we are going to incorporate the vertical stretch first, meaning we are going to multiply all of our y values on that parent graph by -3. Okay, so this is going to be a two-step deal here. So 0, y value of 0 times -3 is still 0. The y value of 1 times -3 is -3. The y value is different. The x value stays the same. Then the y value of 4 times -3 is going to be at -12. Right down here. Okay, so those are the points for, let's see, those are the points for -3x squared. Now we can move all of those points up 2. So I'm going to do that in a different color so as to not confuse here. We'll do it in purple. So each one of these points now will be moved up 2. So that one, this one, and that is your parabola. Okay, so multiply before adding. That's a common order of operation rule, right? In your please excuse, blah, 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 you always multiply before you add or subtract. So incorporate your a value first by multiplying your y values by that number, and then move up or down. Okay? So do your vertical shift, do your vertical stretch or shrink, then move up or down. Always. Okay. Very good. Simple stuff. Great start.